Okay, so after consulting the book a little closer, I realized that what I thought I might be missing uh explaining to you um in these problems right here, what I thought I was missing in explanation, I discovered is actually the result of this proof. So I said I wasn't going to go over the proof, but I guess I will. I'm not going to do it, and I don't want you to worry about having to do it. But here's what the triangle proportionality theorem says. You're going to have two lines that are parallel. That's what they're going to give you, two lines that are parallel. And from knowing that these two lines are parallel, and of course we've got the triangle situation. The one line that's added to this triangle right here is parallel to one of the sides. So what we're going to learn is that you can take these pieces. Now, I'm going to use my vocabulary very carefully. If these two lines are parallel, then each one of these sides of the big triangle are actually transversals. So what this theorem is going to do, it's going to change the way that we can work the problem when we're just dealing with pieces of those two transversals. Okay? So this is saying that the two pieces of the transversal that's over here on the left, you can write a proportion out of that. And that proportion will be, or that ratio, sorry, you can write a ratio out of that. And that ratio will be equal to the ratio that you can make out of the two pieces of the transversal that's on the right side. Now, how is this different? Because while ago we were doing B, because that's the side of the little triangle, over B plus A, the side of the big triangle. And then we were doing making a ratio C over the side of the big triangle, which was C plus D. And that still is true, and it still is valid, and it still works. It's just that it's more complicated than just doing, oh, this piece over this piece is equal to that piece over that piece. So that's what this theorem does. And here is the proof to it. I'm not going to go through it. I'm just going to slowly scroll so that you can go back and look at it piece by piece if you want to. Because for time purposes, if we were doing this in a classroom, you bet we would go through this. See, there's that one right there that we had, the two pieces. You have to add two pieces together. We would go through that, and here they're doing something, getting a common denominator or cross multiplying or something. We would do this, but we don't have time. We've got to do a whole week's worth of material in one day. So while this proof is wonderful and absorbing and all kinds of wonderful things, the bottom line is when we get down here, you can do take the pieces of the transversal and write a proportion. So that's important is because if you go back to this and you can take this problem right here, and instead of having to do like we did right here where you had to write in 15 plus x and then do distributive property, you can just do 12 over 9 is equal to 15 over x. Cross multiply, 12x equals 9 times 15. Divide both sides by 12. And x is equal to 9 times 15 divided by 12 is 11.25. And look, we found x to be the exact same thing as we did when we did it the other way. And this problem over here, now that we have this theorem, we don't have to do x plus 8 to get that long side. We can just do x over 8 is equal to 25 over 10. Cross multiply, 10x is equal to 200. Notice that we got that in our problem anyway. Divide both sides by 10, and x is equal to 20. We got the same value of x here as we did over here. So that makes your problems just that less complicated. So now she wants to find the distance across the lake. You have parallel lines. That's what you have to check for. Make sure you have parallel lines, because with those parallel lines, you get angle similarity. Okay, they give you the angles that you need. And now you're going to take the piece of this one transversal, 27.5 over 54, and that's going to be equal to the pieces of this other transversal, 29 over x. Cross multiply, 27.5x is equal to 54 times 29. Divide both sides by 27.5. And x is equal to, I'm grabbing my calculator now, 54 times 29 divided by 27.5. That looks like it is about 56.9. Okay, so it's about 56.9 kilometers. I am so bad. I am the worst geometry teacher because I'd never put my units. Now state the converse. So remember, the theorem says that if you have a line that's parallel to one of your sides, then the two pieces of the transversals are going to be proportional. So the converse of that would be if you have proportional pieces, then the lines are parallel. Now that's a horrible, because you have to have a picture to know what I'm talking about, but that's the general idea. If you have proportional pieces, then those two lines are going to be parallel. So it just basically, the converse switches what information you start off with. Over here, we were starting with these lines are parallel. Then those means the pieces of the transversal were proportional. If we find out that we have, or if we're given that the pieces are proportional, then we're can say that the lines are parallel. So write a convincing argument about why. Well, because I don't know what they want. I want to get to work in the problems. So what do they want right here? Let's just look at the answer and see. Construct a viable argument. So here's an example. The corresponding sides are in proportion, and the included angle is congruent to itself. So by side angle side for the triangles are similar. Okay. Because they're similar, the corresponding angles are congruent, and then that gives you the lines are parallel. Okay, so there you have it. Convincing argument. All right, so this is for you to do. Check your understanding. I'm not going to stop the video now because I'm just 8 minutes in, but I will put this at the end with the other check your understanding and your practice. So we're going to do this together. Holy smokes, we have a bunch of parallels. It's not going to matter. We're going to do the exact same thing. Parallel, 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 parallel. They're all parallel to each other. So that means that you can take any two pieces from this side and write a ratio, and then take the corresponding pieces from this side and write a ratio. So we're just going to find all these pieces, okay? I like to call my missing pieces a letter, but we'll just do ET. That'll be better. So we'll take these two pieces. So 48 over ET is equal to 48 corresponds to 36, and 24 corresponds to ET. All right, cross multiply and divide. So you have ET is equal to 48 times 24 divided by 36. If I had to do this by hand, I would simplify that 36 over 24. That would make my number smaller. 48 times 24 divided by 36. But since I have a calculator, ET comes out to be 32. Now they want me to find AI. So if I'm going to find AI, I can only have, now ET just came out to be 32. So I can only have one missing piece. So I need to know 3 numbers and have one missing piece. So I'm going to use these pieces right here. So I'm going to do 32 over 40. 32 is from CS and 40 is from CS. That transversal, and so that's going to be equal to 24 corresponds with 32, and AI corresponds with TO. Cross multiply and divide, you get AI is equal to 40 times 24 divided by 32. So 40 times 24 divided by 32. And AI comes out to be 30. So this is 30. And then they want me to find AT. Okay, I'm going to save AT because I'm thinking they're going to have me find OS. Yeah, the reason I'm going to find AT because AT is not a portion of a transversal. AT is a parallel line, and that's the game changer. I'll get to that in a minute. So let's go ahead and find OS. And to find OS, I'm going to use these 4 pieces right here. Okay, these 4 pieces. And that's going to be 40 over OS. 40 over OS. That looks like a 5. That's why I never write S's. Still looks like a 5. And that's equal to what corresponds with 40? 30, which we just found, over 12. So we'll put 30 on top and 12 on bottom. So we cross multiply. OS is equal to 40 times 12 divided by 30. 40 times 12 divided by 30, that gives me 16. So OS is equal to 16. Okay, and then to find ATIO, they want me to find AT and IO and NS. So those are all these the part of the parallel lines. Those are not part of that theorem we just learned. They are not pieces of the transversal. So those are not part of the shortcut of using just these side pieces. And that's where everybody messes up. You cannot find the measurement of one of your parallel sides by using the ratio of these 2 pieces. So the first one that they want me to find is AT. So I'm going to redraw this picture just because I'm going to have to scroll and mess it up. So I'm going to redraw this picture. Ooh, it's really bad. So this is 36. This is 24. This is 48. This is 32. This is 27. And this is what we're looking for. This is AT. This is RE. And this is C. Okay, so the reason that people mess up is because they think that this will work just like we did the other one. Now, this is wrong. What I'm about to show you is wrong. So don't, you can write it down, but be sure you put it inside the wrong box. Okay, people will say, oh, 48 over 32 is equal to 27 over x. Okay, because they got a piece from this side, a piece from that side, and so they go, oh, well, this piece corresponds with that piece. Okay, so this is correct only if you're using it to find another piece of a transversal. These are not pieces of the transversal. These are pieces of the triangle. So while this is correct and this is correct, they are not equal to each other. All right, so you've mixed two things together. So what you have to do anytime you're looking for the length of one of your parallel sides is you have to go back to the two triangles. You've got the little triangle and then you've got the big triangle, and you have to do that like that. So this is 36, this is 48. This side length is 60. Where did the 60 come from? I added those two together. Oh, this one was 27. Sorry. And then this one right here is 70, 80. And then this is x. So to find AT, which is x right here, AT is x. To find x, you have to go back and write the proportions that deal with the sides of the triangle. 48 over 80. You could use 36 over 60. It doesn't matter. 48 over 80 is equal to 27 over x. And that's why everybody messes that. It's like the most missed question on the test. And yes, it is on the final. Most missed question, simply because they get in a hurry and they do the pieces of the transversal. The pieces of the transversal are not equal to the lengths of the parallel sides. So you cross multiply and divide, and this one is 80 times 27 divided by 48. That comes out to be 45. Okay, and you have to do the same thing for IO and NS. I'm going to leave those for you to do because that's really important that I just did that. What was it, 45? I will put it with the video on the answers. So you're going to find IO and you're going to find NS. Okay, what's next? Another one very close to the same thing. If Grant Street and Newton Street are parallel, okay, so mark your picture. Parallel. What is the value of x? Just take any two pieces. These two I know. So 480 over 520 is equal to 450 over x. Cross multiply and divide. 520 times 450 divided by 480. And this one comes out to be 487.5. Are Smith Street and Grant Street parallel? So we have to see if these two are proportional. So we're going to see, I don't know, we're going to see, does 320 over 450, I'm taking these two right here, is it equal? I'm putting a little question mark right there. 350 over 480. So check to see if those are equal. You can do one of two things. You can divide both of these out and see if they came out to the same answer, or you can cross multiply and see if they came out to the same answer. So 320 divided by 450 is 0.71111. 350 divided by 480 is 0.729. So I'm going to say no. But just to maybe show you the different way, if I do 320 times 480, that gives me 1,536,000. And I'm trying to decide if that's equal to 450 times 350. And that's 1,57500. So there's two ways that we just found that they're not equal. So our Smith Street and Grant Street parallel, no pieces are not proportional. Proportional. Okay, check your understanding, lesson practice. So I'm going to do an answer sheet for the check your understandings, those last two questions, and then your lesson practice. And that will conclude all of lesson 18. Thanks for watching.